Learn it fast, learn it smart, learn with us at SOFO. Subscribe now for more videos. Contact us for on-demand and regular tuition classes.
Welcome to concept videos from SOFO Learning. Today we will go over the trigonometric ratio values and calculations. But before we get to the actual calculations, right, let us just take a brief review of the basics of trigonometry. We have a right triangle over here. This is the right angle at 90 degrees and we are focused on this angle theta. So let's define the sides. The side opposite to this 90 degree is the hypotenuse. The side opposite to the angle that we are focused on is the opposite side, and the side that that forms adjacent, that is right next to this angle, is called as adjacent side. Now the ratios being sine equal to opposite by hypotenuse, cosine equal to adjacent by hypotenuse, and tan equal to opposite by adjacent. Now the other 2 points that we want to remember is the relationship between these. So sine squared plus cos squared equal to 1, and the other one is tan equal to sine by cos. So there you have it. That's a brief recap of the basics of trigonometry. Now we will go into these ratio calculations. Now let's think about the values at 0 degrees and 90 degrees for all the ratios, sine, cos, and tan. So let's focus on this sine ratio, which happens to be opposite side by hypotenuse. Now what is interesting is this theta, this angle that we have over there, if it were to come down all the way to 0, right before it becomes 0, the triangle would look like this. So this side would come closer and closer to this side, essentially. So what would happen is that the opposite side is becoming smaller and smaller, and ultimately at 0 degrees this opposite side does not exist. So it would become 0. So opposite side by hypotenuse is 0 divided by whatever it is, doesn't matter, the value is 0. Alright. Now the cos theta at this 0 degrees, the hypotenuse and the adjacent side become equal in size because there is no opposite side. Both these are the same line. So this value will become 1. Alright. Now let's talk about this 90 degrees. Before we get to tan, let's talk about this 90 degrees. Alright. Let's kind of separate these to make a table, and let's focus on these 90 degrees. So back to sine ratio. If it was 90 degrees, this would go up in there, right? Let me draw a little better triangle. What would happen is that this opposite side, so right before it becomes 90 degrees, it would come closer and closer. This side would come closer and closer. The hypotenuse would go all the way. So it would look like this. All right. This would stand up, and this would come closer. So you get what I mean. So what is happening here is that the opposite side and the hypotenuse are becoming equal and equal in there, closer together. So this value will become 1, and this value is getting closer to 0. So this adjacent side would become 0 at that point. So this would be 0. All right. Now tan is sine by cos. All right. So this value is essentially 0 because 0 by 1 is 0. In here we have an undefined. Why? Because the denominator is 0. Sine by cos 1 by 0. So divided by 0 is undefined, and just before 90 this would reach a really high number because cosine is so very small. Next, let's look at the case where the angle is 45 degrees. Now, if this angle is 45 degrees, obviously this angle has to be 45. So when two angles are equal, we get an isosceles triangle. So this side and this side has to be equal in size. Now, for the simplicity of calculations, let's imagine this side to be size 1, and so this side has to be size 1. Now, what would be the size of the hypotenuse? Hypotenuse h would be equal to 1 squared plus 1 squared, square root of the entire thing. So it is square root of 2. Alright. Now it's fairly easy to calculate the ratios. So sine of 45 degrees is 1 by square root of 2. Cos of 45 degrees is equal to 1 by square root of 2, and they happen to be equal. And tan, since they are equal, tan of this 45 degrees is equal to 1. Okay, now we have a triangle here where all sides are equal and all angles, all these three angles are equal. So that makes it 60 degrees here, 60 degrees here, and this total is 60. Now we divided that equally 50-50 using a straight line that runs perpendicular to this side, and we would say that this is 30, and obviously the other side is 30 as well. Now proportionally this side divides into A here and A here. So this side is 2A, this side is A, and for this right triangle right here, A, B, C, for this right here, let's calculate what would be the size of this side. Alright, so this side would be, so this is, let's call it the square root of the square 4A squared, the square of this side, minus the square of this side, all right, A squared. So this is equal to 3A squared, and that is root 3 times A. Now we have 30 degrees and 60 degrees in here, so let's imagine what would be the sine of 60, and that would be this side. So we know that this is root 3a, so root 3a divided by this 2a, and that is root 3 by 2. Now let's just do cos 30, no, sine 30, I'm sorry, this sine 30, and that would be this a divided by this 2a, this opposite side by the adjacent side, so a by 2a, and that is 1/2. Now I'm sure you can do this at home, but try to calculate the cos theta and tangent based on these two values using these ratios. Now let's think about how we perform some calculations of sides of triangles. So there are three simple steps involved in these calculations. The first one is fix the right angle. Well, we have two examples here, and what we need to think about is this is the right angle. So that makes the definition of hypotenuse possible. So we have the hypotenuse right here. This is the right angle, so this is the hypotenuse. Now fixing the hypotenuse helps us generate the ratios using the rest of the sides and rest of the angles. So therefore we now need to fix the angle for trigonometric ratio. For example, in this case I have taken this as the angle, that is 30 degrees. All right, And in this case, I have taken this angle as 60 degrees. Now fixing this angle helps us determine the ratio. So now the sine of this 30 would become this side divided by hypotenuse. This is the opposite side. For this 60, this is the opposite side, and this is the adjacent side right here. Now for this 30, the adjacent side is right here. Now the third step is apply the ratio. All right. So for imagine, let's apply the tangent ratio for this 30, right? So tan 30 would be this opposite side divided by 10. This opposite side divided by 10. So in this equation, this is the only unknown, and therefore we can calculate that. Now if we knew this side, we can calculate the hypotenuse, and therefore we get all the angles and all the sides. The same principle applies here. Let's just try that one more time. So if we know this side, if we were to think about this side or this hypotenuse, the idea is we can try tan again. All right. So tan of this 60 degrees would be 50 divided by the adjacent side, and we can find this value and therefore the hypotenuse and all other values. So remember the three steps: fix the right angle, fix the angle for the ratio, and then apply the actual ratio between the sides that we need to, and then calculate the rest of the unknowns. Thank you so much.